Okay, so now let's talk about the area and the volume problems in the chapter 5. Okay, in the chapter 5. So we always have two directions to cut, right? Two directions to cut. So let's say first we cut this way, right? We cut this way. So we want to find the area between the curve y is equal to x and y is equal to x squared, right? So first you have to know the bound, right? So they meet here at 0 and they also meet here at 1. 1 squared is equal to 1. So our integral will be from 0 to 1, right? From 0 to 1. So now we expand this green cutting line a little bit. What do we get? We get a small box. Right, we got a small box, and then the small box has the bottom length delta x, right? Small box has the bottom length delta x, so that means for this green cutting line, we will only use letter x for the integral, okay, for the integral. So later we will cut it again, change the direction, then you will have the cutting line, and then only use letter y, right? Only use letter y. So here we should only use letter x, okay, letter x. So now we label these 2 points on top and bottom of the box. So this is A, this is B. So now first question you should answer is, what's the coordinate of A and B in terms of x, okay, in terms of x. So that's why we have to figure out which letter, right, which letter. So A is on the line y is equal to x, so A is xx, right? Xx. xy, so y is equal to x, so A is xx, right? So B is on the blue line, right? B is on the blue parabola, so B is xy, and then this y is equal to x squared, so this is x squared, okay? X squared. So you write down the coordinate of A and B, and if you like, you can also label them here. So now what's the length AB, right? What's the length AB? So the length AB, it will be x minus x squared, right? Top times bottom. Then the area of the small box, this will be x minus x squared delta x, right? Yeah. So now the area between the curve y equals x and y equals x squared will be A, so this is integral from 0 to 1, and then you put the formula here, change delta x to dx, right? Change delta x to dx. So that's the last thing you should do. That's why we use a small box, right? Small box. So you got the area for the small box, change delta x to dx, you got the integral, right? You got the integral. So now antiderivative, right? Half x squared minus 1/3 x cubed, and then this is from 0 to 1, and then you get the answer 1/6. Okay, 1/6. So this is the area of problem using letter x, right? Using letter x. Okay, so now the same area problem, we can also cut the other way, right? The other way. So let's use orange color, right? Let's use orange color. Suppose you cut it this way, right? You cut the area this way, and then this time that's our small box, the orange box, and then this will be our A and B. So A is on here, B is on the blue, right? B is on the blue. Okay, yeah. So now if you look at this small orange box, right, the height will be delta y, right? So delta y. So delta y implies we only use letter y for this new cutting, right? For new cutting, okay, for this new cutting. So now we need to write down the point A and B in terms of letter y, right? Letter y. So A is x comma y. So it's on the line y is equal to x. So x is equal to y, right? X equal to y. So this is y, y. Okay. So here that's the line, right? Y is equal to x. So for B, this is a little bit harder. So we got x comma y, and then y part is okay, we can keep it. So now we have to solve x in terms of y, right? So solve for x. So the equation is y is x squared. Solve for x, so square root of y is x. Okay, so here should be square root of y. Okay, square root of y. So that's our a and b, right? That's our a and b. So the bound for the integral is the same, right? It's from 0 to 1. So now from a to b, the distance in terms of y, so now this will be radical y minus y, right? Bigger one minus smaller one. Okay, bigger one minus smaller one. Okay, yeah. So that's the length AB, and then the small box, the area of the small box, it will be delta y times this. So the area of the whole region between y is equal to x and y equals to x squared, A will be integral 0 to 1, radical y minus y, change delta y to dy, right? Delta y to dy. So antiderivative now. So this is 2 over 3 because y, radical y is half power, right? Half power. So this is 3 over 2 minus 1 half y squared. And then we plug in 0, 1. We got the same answer. Okay, we got the same answer. So for the area problem, you have freedom to choose which way to cut. And then the way you are cutting, you expand it a little bit to get a small box. So that small box, the small side is delta y or delta x. That's give you the letter for the integral for the whole calculation. Okay, yeah. So for the exam, for the midterm exam, you have to show me what's your a and b first. Right, A and B first. So that's also labeled AB on the curve, right? Sorry. So I should use YY here. And this is radical Y, Y. Okay? Radical Y, Y. So that's the two area problem, right? Two area problem. So now we have the same picture. We can find the volume by rotating this purple area, right? Purple region. Okay, purple region. Okay, so this is the new question, right? New question. So suppose this we use letter R for this region, right? We use letter R for this region, the purple part. So this one is between y is equal to x and y equals to x squared, and then we rotate it about the x-axis. So here is x-axis, here is the y-axis. Okay, and then we get new solid, resulting solid, and we want to find the volume of this thing. Okay, volume of this thing. So now still we have two ways to cut. Okay, two ways to cut. One is called cross cut, the other one is parallel cut. We will get two completely different calculations. Okay, completely different calculations. So now let's look at the cross cut. Okay, let's look at the cross cut. So for volume question, we always write down what's the axis of the rotation first, right? Axis of rotation is x-axis. Okay, this red part. Okay, this red part. So we rotate this way, right? Yeah. Go outside the screen and then go to the bottom and then go back. Okay, go back. So that's the rotation. Okay, so now what is cross cut? Cross cut is a cut that you will cut the axis of rotation. Okay? Yeah, so let's write it down. Cross cut. We will cut the axis of rotation. So for this problem is x-axis, right? So now we need orange cut that cut the x-axis. So this is the cross cut. So now we get 2 points A and B here. Okay, and then we also label this point C, right? This point C. So this is where the cut on the x-axis. Okay, on the x-axis. Okay, so now instead of imagining the whole region R is rotating, we imagine there's A and B, right? The curve, the interval between A and B is rotating, right? It's rotating. So when you rotate A and B, so the center of the rotation will be C, right, will be C. Okay, so now let's draw a two-dimensional picture, right? Two-dimensional picture. So here is C, and then B go around C in a smaller circle, and then A go around C in a larger circle, right? In a larger circle. And then this orange interval between them give you this orange annulus. Okay, orange annulus. Okay, so that's the rotation. That's why C is important. That's the center, right? When you rotate, C is still on the x-axis, so C is not moving, right? C is not moving. Okay, yeah. So now first step, we should find what's the area of this annulus. Okay, area of the annulus for crosscut. Okay, for crosscut. Let's say this is R2, this is R1. Okay, so the area of annulus A will be pi R1 squared minus pi R2 squared. So it's the bigger disk minus the smaller disk. Okay, bigger disk minus smaller disk. So still we will label the A and B, right? Label the A and B first, and then we will know the height, how far B from C, and then how far A from C. Okay, A from C. Yeah, so let's change this A to area, because later we will have point A and B, right? Area of the annulus, right? So now what's our point A and B? So again, we still need to know what's the letter we are going to use, right? Yeah. So we imagine we expand this orange interval a little bit. We got this small box. Small box is delta x, so we use letter x, right? We use letter x. So point A is x. So point B is x squared. So we don't need to repeat that, right? We don't need to repeat that. Then what is R1? What is R2, right? What is R1? What is R2? So R1 is B to C. So R1 is the y coordinate of B. So R2, sorry. So R2 will be x squared, and R1 will be x, right? R1 is A to C. R2 is B to C. Okay, B to C. So now the area. The area will be pi x squared, that's R1 squared, minus pi R2 is x squared squared. So that's x to the fourth, right? X to the fourth. So it's pi x squared minus x to the fourth. So you can factor out delta x, factor out pi, right? Factor out pi. Okay, yeah. So we call this A of x is the area, and which depend on x. So it's a function of x, right? Function of x. So now what's the volume? Volume is just the integral. So bound of the integral is always from 0 to 1, right? Because I didn't change the picture, right? From 0 to 1, ax dx, okay, dx. So you can imagine this ax, you expand it a little bit, you got a small rectangle, and this you rotate the whole small rectangle. So the volume of that rotation will be ax times delta x. And then you change delta x to dx, you got the integral. Okay, you got the integral. So that's the formula for crosscut is ax dx, integral of ax dx, right? So this will be 0 to 1 pi x squared minus x to the fourth dx. So anti-integral, antiderivative, x cubed over 3 minus x fifth over 5, 0, 1, and then you got the answer is 2 pi over 15. Okay, 2 pi over 15. So for this part, right, for this part, crosscut, you will always get an annulus, right? So area of this annulus is important, okay? Area of this annulus, A of x, depend on x, that is important. So you have to show me what is A, what is B. That will give me the radius, R1, R2, and then show me what's the area of this annulus. And then ax dx will be the volume. Okay, integral of ax dx will be the volume. So that is the crosscut, right? That is the crosscut. Okay, so now second method, we will cut parallel to the rotation, x of the rotation. Okay, Okay, so now axis of rotation is still the same. Is the x-axis. Okay, so now we want to cut horizontally. We are not going to cut the x-axis, we will cut the y-axis. Okay, so this is the second method. Okay, second method. This is called cylinder shell in the 5.3, right? 5.3. Okay, so this is parallel cut. The cutting line is parallel to the axis of rotation. Okay, we didn't cut axis of rotation. We cut the other one, right? Axis of rotation is the x-axis, but we cut the y-axis. Okay, y-axis. So that's the big difference, right? That's the big difference. So now we still have this A and B, right? A and B. This is our A, this is our B, and again we expand this a little bit to get a small rectangle. Okay, small rectangle. So that's delta y. We will get an integral with respect to letter y, right? So now everything we need is letter y, right? Letter y. So the height here is delta y, right? Delta y. Okay, yeah. So now again, let's understand if you rotate AB, right? Only the orange curve AB, what you will get, right? What you will get. So A go around the x-axis, B go around the x-axis. So basically, you will get two circles for A and B, and they're the same size now, right? Same size now. So this is A, this is B. Okay, and then the whole orange curve, every point on the orange curve, basically rotating the same way. So you will get a cylinder. Okay, you will get a cylinder. So you imagine this AB is a horizontal curve, and then you go out of the screen, and then go to the bottom side, and then go to the back of the screen, and then go back to AB. Okay, go back to AB. Okay, so you will not get annulus this case. This case you will get a cylinder. Okay, a cylinder, and every point is moving, right? Every point is moving. Okay, so there's no center C which is not moving in the first case, like the other cross-cut case. Okay, because we didn't cut the axis of rotation. Okay, axis of rotation. So now we call this distance AB is the height of the cylinder. So we use H, right? We use H. So that's the distance from A to B, right? A to B. So for this particular case, it's B minus A, right? B minus A. So again, let's label AB using letter Y now. So this is YY. This is radical Y, Y, right? We already did it, right? We already did it. So this will be radical Y minus Y. Okay, so the x coordinate for B, so that's radical Y minus the x coordinate for A, right? For A. So that's the height of the cylinder. And then what's the radius of this rotation? What's the radius of the rotation? So let's use the red color, green color, right? So this is the radius of the rotation. Okay, A and B have the same radius, right? Same radius. So that's the R in this circle, right? That's R in this circle. So B go around the center point, let's say B star. A go around the center point, A star, right? The radius is R, and then from the coordinate, you can see they are the Y coordinate. So R is Y, right? R is Y. So that's the radius of the rotation, okay? Radius of the rotation, okay? Yeah. Okay, so now what's the area of the cylinder is 2 pi r times h. Okay, 2 pi r times h. Okay, so now we need area of the cylinder now. So this is 2 pi r is the length of the red circle here. You can choose the top or the bottom circle, circle of A, circle for A or B, right? They're the same length, right? Same length. And then times the height, right? Times the height. So this is h. Okay, so that's the area, right? That's the area. Okay, yeah. So area is, for this particular case, 2 pi y, and then radical y minus y. Okay, radical y minus y. So now let's expand this AB a little bit. You rotate the whole red small box there, right? Red small box. Then you got the volume of the small box the volume of the rotation for this small box. So this will be the area times delta y, right? Times delta y. Okay, the area of the cylinder times delta y. Okay, and then the whole volume will be just integral of this v of the small box. You change delta y to dy, right? Change delta y to dy. Okay, yeah, so now v of the small box is 2 pi y radical y minus y times delta y. So we got the integral 0 to 1, 2 pi y radical y minus y dy, okay, dy. Okay, so that's the volume of the rotation of the whole purple region R, okay, purple region R, okay, yeah. So for this method, we didn't cut the axis of rotation, we cut the other one. Okay, so it's a parallel cut. And then when you rotate AB, you got the cylinder. So first you find the area of cylinder. And the area of cylinder is a function of y for this particular case, right? So it's AY, right? It's AY. And this is the formula. Is the length of the top or bottom of the cylinder times the height of the cylinder. Okay, times the height of the cylinder. Okay, and then V is just the integral of AY, right? AY. Okay, yeah. So maybe let's put it here. So V is just the integral 0 to 1 AY dy, and that is the okay, that is that. And then you just use the anti-derivative. You can find this integral. You will get the same answer, right? I don't have space, so I will skip that part. You will get the same answer, 2 pi over 15. Okay, 2 pi over 15. Okay, so essentially is the same volume, but we look at the volume in two different directions. Right? So you first try to understand the area in two different directions. Okay? So if you use letter y, or everything has to be letter y, right? Integral is y, AB is y, and the area is AY, right? So if you use the letter x, everything is letter x. Okay? Yeah. So area is easier. So now what is volume? Volume, we have two ways to cut. You cut the axis of rotation, that's easier. It's called cross cut. If you didn't cut the axis of rotation, it's harder. So the easier one, cross cut, you get annulus. Integral of the area of the annulus is the volume. The harder way, the parallel cut, you will get a cylinder, and then the integral of the area of the cylinder will be the volume. Okay, will be the volume. So you either use the area of annulus or you use the area of the cylinder. Okay, so that's the two ways for the volume. Okay, two ways for the volume. So that's why in 5.3 this is called a cylindrical shells, right? You get a cylinder, and then you expand it a little bit, you get a shell, right? You change delta y to dy, you got the volume.